As you gaze up into the vast, endless canvas of the night sky and witness the shimmering dance of billions of stars, one timeless question begins to echo in your mind. Are we truly alone in the universe? For centuries, philosophers, scientists, and dreamers have searched for the answer. And now, with the dawn of a new era in space exploration, humanity may finally be closer than ever before. That leap forward comes in the form of the James Webb Space Telescope, also known as JWST, a revolutionary observatory designed to peer deeper into the cosmos than any telescope before it. Recently, JWST turned its powerful eye toward a mysterious world known as K2-18b, an exoplanet located about 120 light-years away in the constellation Leo. At first glance, K2-18b may seem like just another distant planet. But deeper analysis revealed something extraordinary. A planet unlike any other K2-18b is what astronomers call a sub-Neptune, larger than Earth, but smaller than Neptune. This class of planets doesn't even exist in our own solar system, making it both fascinating and difficult to understand. Sub-Neptunes are often described as in-between worlds, not rocky like Earth, yet not massive gas giants like Jupiter. Their strange nature has made them one of the biggest mysteries in modern astronomy. But what truly captured scientists' attention was K2-18b's potential to support life. Inside the habitable zone, the planet orbits a cool red dwarf star called K2-18, much closer than Earth orbits the Sun. Despite this close orbit, the planet may still have temperatures suitable for liquid water because red dwarf stars are far cooler and dimmer than our Sun. That places K2-18b inside what scientists call the habitable zone, the region where conditions might allow water to exist in liquid form. And then came the breakthrough. Using transit spectroscopy, JWST detected water vapor in the planet's atmosphere. Soon after, researchers identified traces of methane and carbon dioxide, molecules often linked to potentially life-supporting environments. But one discovery stood above the rest. A possible biosignature. JWST also detected hints of a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced almost entirely by living organisms, especially microscopic marine life like phytoplankton. If future observations confirm its presence on K2-18b, it could become the strongest evidence yet of possible life beyond our solar system. A planet with potential. Scientists are still cautious. No one is claiming alien civilizations have been found. But K2-18b may represent something equally important: a world with conditions capable of supporting microbial life. And that possibility is enough to reshape how humanity searches for life in the universe. In Part 2, we'll explore the revolutionary theory of Haitian worlds, dive deeper into K2-18b's atmosphere and climate, and discover why this strange planet may redefine our understanding of habitable worlds forever. Welcome back. In Part 1, we explored the remarkable discovery of K2-18b, a distant sub-Neptune exoplanet showing possible signs of habitability. But to truly understand why this planet matters, we need to explore a new and groundbreaking idea in astronomy: the Haitian world theory. In 2021, astrophysicist Niku Madhusudan introduced a bold concept: a new class of planets called Haitian worlds. The name combines two words: hydrogen ocean. Haitian planets are believed to contain massive global oceans hidden beneath thick, hydrogen-rich atmospheres. Unlike Earth, these worlds may be up to 10 times Earth's mass and nearly twice its size, yet still capable of supporting liquid water. And K2-18b may be one of them. Why Haitian worlds matter: one of the biggest challenges in finding alien life is discovering planets that are both detectable with our current technology. Potentially habitable Haitian worlds solve both problems. Because they are larger than Earth, they are easier for telescopes like JWST to study. And thanks to their thick atmospheres, they may remain warm enough for liquid water even under extreme conditions. Some scientists believe microbial life could survive in these deep planetary oceans, much like extremophiles on Earth that thrive near hydrothermal vents or acidic lakes. Life on Hycean worlds would likely look nothing like life on Earth. But it could still exist. How JWST studied K2-12B. The James Webb Space Telescope analyzed K2-12B using a technique called transit spectroscopy. As the planet passed in front of its star, starlight filtered through its atmosphere. JWST then examined how different wavelengths of light were absorbed. This allowed scientists to identify the chemical fingerprints of molecules within the atmosphere. From only a few hours of observation, JWST detected water vapor, methane, carbon dioxide, and possibly dimethyl sulfide together. These findings paint a picture of a potentially habitable environment unlike anything in our solar system. What happens next? Scientists stress that more observations are needed before any conclusions about life can be made. The detection of DMS is still tentative and requires confirmation. But regardless of the outcome, K2-12B has already changed the conversation. It has shown us that habitable worlds may not need to resemble Earth at all. And if Hycean planets are common throughout the galaxy, then the chances of life elsewhere in the universe may be far greater than we ever imagined. The search has only just begun. And somewhere among the stars, the universe may already be waiting to answer humanity's oldest question: are we alone?